Yes.
Hey, what's up, everybody? We're back for another C++ lesson, and I have my son, Alex, with me. How's it going, Alex?
Hello, everyone.
We've been in deep philosophical discussion for a little while, but now we're back, and we're here to talk about one of our favorite subjects, which is coding. And today we are going to do constructors. So constructors and a little bit about destructors. And so I haven't prepared a presentation for this tutorial. So we're just going to jump straight into Xcode, and I will do that now by sharing my screen.
Nah, who needs presentations anyways?
Exactly. We got to get to the good stuff. So here we are at a blank C++ project, and we have literally nothing. So first thing that we're going to do is we're going to declare an object. And let's call this object something like shape. And we will give it public and private sections. And let's say that we want to give an int width. We will initialize this to 0 and int height to 0. And now what we could do is we could just, if we wanted to, we could create a shape by just saying shape, my shape. And if we try to compile that, we could unuse variable my shape, but everything compiles fine, right? So what it's done is it's actually constructed a shape. So we have created an object. All of that is stuff that we've already done, right? Yeah. I can't hear you.
Sorry, I was muted. Yeah. Yeah, we've discussed this. Yeah.
Yeah, we've discussed this. So now what we're going to do is we're going to talk about constructors. So as we can see, an object's been constructed, and the thing about C++ is that if you don't declare a constructor, so you may or may not have used constructors before, but there's no constructor here explicitly declared. And what we can see is even though we haven't explicitly created what's called a constructor, C++ actually constructs an object for us. Okay. Now we can explicitly declare a constructor. Okay. And the way that we do this is by using the same. So this looks like a function, except it doesn't have a return type, and the name of it is the same as the class name, shape, like that. Right?
Right.
That's it. We will run this again, and we still get build succeeded. So that's fine. So this is what a constructor looks like. Okay, so this is what is actually called when an instance of an object is created. Okay, and we can test that by doing a console out. We'll say constructor executed. Then what we can do is we will just compile this, and we should get console out where we see constructor executed. So that would have been executed on line 25, and the object was constructed. Now you have this other concept called destructors. Okay, and the difference between a constructor and a destructor is just that you put a tilde in front of the class name. So it's the same thing as a constructor. So you have the class name, except it has a tilde. And this is what happens when your object goes out of scope or that it's destructed. Okay. And we could do that. And we could test this by just saying destructor.
So a constructor is different than an initializer, right? Or are they the same thing?
Mm, well, a constructor, I think a way of saying it is a constructor is an initializer. So it initializes an object of that class.
Okay.
Okay. But you have another thing that's called an initialization list, and that's a little bit different.
See,
Um,
I'm thinking of initializers from Swift. And if constructors are similar to that, does that mean that you can have well, I'll just let you get to it. You
okay.
you, you can go on.
Yeah. Okay. Cool. So what we will do is we will test to see when the constructor is hit and when the destructor is executed. So what we'll do is we will do a breakpoint just on int main and hit play. And then we see that there's down here, we have nothing. We see that width is randomized to a value. Height is not initialized yet. And then if we do step over, we see our constructor is executed, right? We're still in
Hmm.
scope of int main.
Yep.
And then when I hit this again, we'll get this, this will bring us to assembler, but you see that the destructor was executed because it went out of scope. So now the destructor executes.
So that so when it destructed, you didn't explicitly quote unquote destruct it. You implicitly destructed it because it's outside of the scope of int main.
That's correct. Yeah.
Okay.
Yeah. Yeah. So all good so far, right?
Yep. Yeah.
Cool. So now we can, sometimes what you'll see is where a constructor might need default arguments in order to initialize it. So for instance, if we were creating a shape, two things that we may want to know when we create a shape is we may want to make the user of this class give the shape a width and a height to initialize it,
Mm.
right? So what I might say is we might have int w, int h that we pass in the shape on creation. And then what we do is we will say width equals w, height equals h. Okay. And right away, we see on line 32, we have an error that says no matching constructor for initialization of shape, right? So what this means is that the constructor, when we construct the object, it's saying, hey, we need two parameters in order to initialize this. And we aren't doing that in this case. Okay. So what we need to do is we need to give it two numbers. Let's just say 3 and 5, like that. So we've given it a width and a height that's happening when we're creating an object of type shape.
Mm.
Okay.
Yep.
Now, another thing that I may do that's just a side note is I may want to make sure that that the shape, that the inputs for this shape are actually valid. So a shape couldn't have a negative width or a negative height. That wouldn't really make sense, right?
Right.
So what I may want to do, just as a side note, is I might want to do what's called an assert. I don't know if we've talked about asserts before, but I could do this thing called an assert where I say W is greater than 0 and H is greater than 0. So this is a safeguard that will stop execution if the input is not greater than 0. So let's execute it once where it will be execute fine. And we see everything executed fine. And now let's change this 3 to negative. And let's see what happens. So we see that we have this hit program assert, and then it just stops on this line where it says, hold on, W is supposed to be greater than 0, and H is supposed to be greater than 0. And we see here that if we hover over the W, we see the W is -3. So that's why we've hit that assert there. Okay.
So 2 questions.
Yep.
One, is the assert basically the same thing as like almost like a break keyword where it just breaks out of the shape and it'll continue on with the rest of the code, or will it stop the code at that moment?
Well, this is there's a more complicated way to answer this, but let's just say for now that it pauses the execution of the code.
Okay.
Yeah.
And the second question is that you have a constructor, which I'm getting the impression that this is like a mandatory constructor, as in you have to put in the int w and the int h or arguments for those numbers. But can you make it so that if for whatever reason the programmer doesn't use that constructor, you can have default behavior, like it'll default to 0 or some arbitrary number?
Yeah, so you can do what's called oh, I'm going to get yelled at because I don't remember the technical name for this, which is going to be I think it's overloading, or basically you can declare I'm sorry, the name's escaping me at the moment, but basically you can create 2 different types of constructors. So in this instance, let's say that we want to create one where we give the user the option to not declare any arguments. And in this one, we would say, okay, maybe we will make the width equals 1 and height equals 1 by default. So now I can do either one of these. Okay, so I will do it like that. And we see that it worked, that worked just fine. Right, so I should do this here as well because it's a constructor.
Oh, okay. Yeah, I was confused.
So you have that, or you can do a shape where you give it your own arguments. Yeah. So these are alternative. Once again, I've forgotten the actual correct name, but you could basically have alternative constructors depending on the scenario that you're using, and this is something that's very common.
So I'm not okay. I have another question. I'm not sure if you'll understand what I mean by this, but can you? So in Swift, there's this construct or initializer called a convenience initializer, which basically refers to it's designed for convenience. So let's say you have a circle, right, which has a predefined radius and a circumference. So a convenience constructor or initializer is for when you want to define, say, the circumference before the radius. But in that case, the syntax would require that a constructor refer to another constructor. So is that an option? Like, can you make a constructor which isn't the default constructor in itself, but it serves as a reference to another constructor?
I don't think that I understand your question correctly. So I'm going to say I don't know. but there is one other thing that you could do that I will show you, which is called an initializer list. So let's eliminate this one that doesn't have any arguments for a moment. So we only have our one constructor that requires a width and a height. And let's create another class. And let's call this, let's see, I don't know. I'm just going to call it playground. And now inside playground, so this might start getting a little bit confusing for you. Inside playground, I'm going to declare a shape. Okay, so something like this. So I'm just going to get rid of that for a moment. Now you're in a situation where shape has to take a width and a height. Okay.
Mm.
So you could do that one of two ways. You could do that the way that we did it before, just declare some initial arguments. But what if you wanted the user? What if you wanted the user to supply those at some point, right? Or on the construction of the playground, let's say. So
Sure.
now we do something. So I'm going to show you the way that we do it just before we allow the user to supply their own arguments. But you can do this, right? So there's this interesting syntax where you do this. So it's a colon, and then you do my shape. And now you supply it with the default arguments.
Mm.
Okay. And now we have playground, my playground. Okay. And this should execute fine. So build succeeded, no problem. Okay. So this is what's called an initializer list, which means that on initialization of your shape, you have to supply a width and a height. Okay. And then you can, to further just exhibit what's possible here. Now I can supply playground with default constructor arguments. We can pass those into my shape.
Hmm.
And then we can supply those as arguments when we're actually constructing a playground. So this is another thing that you see very, very commonly, where you have to take the width and the height, and you pass it through one class, and then it goes into another, and then it goes into an instance of another class.
Mm.
So that's something that's very, very common.
So would this be along the same lines as inheritance? Because I'm assuming that when you inherit, like let's say you had a circle, or just because a circle is a shape. If you had a circle class and inherits from shape, it would have to inherit the shape's constructors, right?
Mm-hmm. That's correct. Except, well, playground is not inheriting shape in this situation. So
Okay.
playground is not a shape. Okay. Playground is simply passing arguments that you've supplied it into your instance of shape that needs to have default arguments. So
Mm.
I know that this colon is also used for inheritance. So just to show you what we mean by inheritance, we will say, we will do another class circle, And now that's where we do the colon right there
Hmm.
with class. And we will say public shape. Okay. And then hopefully I will get this right. The first time I always seem to mess this up. And then of course, shape will need the default arguments of width and height. So let me try to remember exactly how this. So we need to make circle an int w and an int h. Then the question is, how do we pass that into? So we got constructor for circle must explicitly initialize the base class shape, which does. So I believe that it's like this, like that. So that is how it works. Okay. So because shape is the base class and then circle is the derived class of, so circle is inheriting shape. Shape had a default constructor that required a width and a height. And now, and so what we need to do is we need to supply those to our circle. So this is actually, so this is just basically saying, okay, circle is a shape. Shapes have widths and heights. So I need to supply that. I need to supply the width and the height. Okay.
Hmm.
Now this is going to get, it's going to get even more complicated. Okay. Because I can't, so if you look here, I say circle. So you can actually access the base class variables through your derived class. So you'll see what I mean here. So if I say circle dot width, let's just say circle dot width equals 5. Or actually, I'm sorry, it's just width because you're just in the. So you see here when I say width, when I try to type width, we see this is crossed out, right? And we'll see
Hmm.
what happens here. So let me just try to set the width to 5. So we see this problem. Width is a private member of shape. So now what we need to do is this makes it a little bit, this introduces another another concept called, there's this third type of access called protected.
Oh yeah, I've heard of protected. Yeah.
Yeah. So now protected means that derived classes can access the variables of protected variables of the base class.
Hmm. Okay.
Yeah.
So is there any other way, like no matter how convoluted, for you to access width and height if it was private? Or is that basically the only way?
As far as I know, no. But a C++ guru will probably know a way. And I think there are ways that you could do it, but I can't think of them. I
Oh
can't think.
wait, you can make a pointer to it, right? I forgot how you did it, but it's like you return you create a pointer of the same type. So like int get width. You taught me this, I think. It was like int get width,
Yeah.
and then you return width, something like that.
Yeah. It was something like a pointer to the base class. Yeah, I can't remember. Yeah.
Something like that.
Yeah. There was something that a C++ guru actually showed me, but yeah. So yeah, so that's it. That's it right there. That's a little bit about constructors, about passing uh passing constructor arguments through it when you inherit from from a class that takes constructor arguments, uh,
Mm.
also initializer lists, and then like I said, destructors. There's more that you could do with destructors. So normally, if you had some sort of memory allocation or any sort of resources that needed to be eliminated or properly cleaned up at once the shape goes out of scope, then you would put that in the destructor. Okay, so an example of this might be a pointer. So let's say that you should not do this. So this is going to get into some funny business, right? So area equals new int. We'll store a value of 5. So now what we've done here is we've created a pointer, old school pointer
Uh,
of type area. So we've allocated some memory, and in here, what we would need to do is we would actually need to delete area at the very end. Okay, and that cleans up the pointer there. So so this is a raw pointer that allocates memory. And then
huh.
what I've done is on destruction, I need to clean that up because if I don't, then we have what's called a dangling pointer. So we have memory that's been allocated that we now, since we've destroyed shape, we wouldn't have access to this anymore. There's no way for us to access that, but yet
Right.
it's
Okay.
still taking up space in our memory.
Mm.
Yeah.
Hmm.
Yeah.
Okay. Yeah. That all makes sense. That all makes sense.
Yeah. So a lot of stuff there, a lot more complex than I intended this tutorial to be, but there you are. Yeah. So raw pointers, don't use them. Okay. So I will show you just very quickly. So let's say that we make this area into a stood unique pointer of type int. We will just call this area. Okay, so this is the benefit of using a unique pointer rather than a raw pointer. And so now, it's complaining that we can't delete it. So now we need to do area equals stood, make unique. It's a little bit more syntax, but
Yeah, I remember struggling with this when you first told me.
yeah. So it's like that. And the benefit of this is that you don't have to remember to call delete when this is destroyed.
So does Xcode throw any errors if you don't delete a dangling pointer, or does it just is it like one of those hidden bugs?
It's a hidden bug. So
Uh,
it's not even it's I wouldn't even call it a bug because it's just that it doesn't know that it's supposed to do that.
mm.
You do actually have tools that you can use for things like that. It's called the it's getting way off the subject, but um, so in here in diagnostics, you have so I think it would be address address sanitizer that you would want that would actually look at that and say, hold on, the object's been destroyed, but you still have this this memory that's occupying a space, even though the parent object has destroyed it.
I find compilers so interesting because I don't know how they catch errors. Like it's almost like it's simulating the program in its head. Or I mean, obviously there's clear syntax errors that you could have a glossary and just compare it. But
Hmm.
things uh like sanitizing the RAM addresses and stuff like that. I don't know how it does that. It's fascinating stuff.
I'll be honest, I don't know either. That's a little bit beyond my pay grade, but but it also does things like optimizing your code as well. So there are certain
Mhm.
things like if it sees unnecessary loops or unnecessary, it actually it actually optimizes your code and makes it faster in ways that may be intended or may be unintended. And that's where you get into different compilers. So you can use this. So you have GCC, you have Clang, and they have different behaviors that work better on certain circumstances, things like that. That is a little bit beyond my realm of understanding, but yeah, all of that's out there for you to explore.
Good stuff.
Cool. Yeah. So yeah, if you're still with us and you really enjoyed that tutorial, be sure to give it a like and subscribe, and we will see you next time. See ya.